So now we want to talk more about the parts of the atom and how they contribute to making each type of atom, called an element, different. So the parts are these electrons, protons, and neutrons, and any one type of atom, a collection of it, is called an element. So carbon was an element, but what is an element generally? Well, an element is the fundamental stuff everything's made of. And you might say, hold on, didn't you just say a couple of slides ago that an atom is the fundamental stuff everything's made of? Well, the atoms are the building blocks of everything. The atoms are the particles of elements. So the elements is the stuff. The atoms are the particles of the stuff. Okay? Now, a long time ago in ancient Greece and in other ancient literature, we find people thinking that there were 4 elements. So the 4 elements are earth and air and fire and water. And nowadays we look at that oversimplification and we think, what idiots they were for thinking that everything was composed of just 4 things. We now understand that there are about 100 naturally occurring real elements, and that everything is composed of these 100 different elements. And those are the natural ones. There are some additional elements that are man-made, which might seem weird that you can make elements, but I'll briefly explain how later. The elements are arranged on this table that you've no doubt seen. It's probably hanging up in your science classroom, and maybe if you're really cool, hanging up on a wall in your bedroom, or you could even have it on a t-shirt or something if you're absolutely really cool. This is called the periodic table of the elements, and we'll talk more about it in a second. Here, one of the elements, carbon, is shown. Its little box in the periodic table is shown magnified to learn a little bit more about it. The element always has a name. This one's carbon. It's not always written in the entries on the periodic table, but the element symbol, the letter C, is written. That's for carbon. Then we have 2 numbers. One is the atomic number. That's going to be the most important number to us. And then the other number is the atomic mass number. And we'll briefly talk about that. So the type of element, all of the 100 or so elements of the periodic table are each defined by their number of the subatomic particle protons that they have. That number, the number of protons that they have, is the atomic number. So for carbon, we said that's going to be 6. So carbon has 6 protons. 1, 2, 3, 4, 5, 6. You can't see 5 and 6 because they're behind. These are the protons in the nucleus. And those protons, the fact that there are 6, makes it carbon. If it had more than 6 or less than 6, it wouldn't be carbon. It would be some other element. Now there are other subatomic particles here. There are the neutrons in red. They're not literally red, but they're drawn in red here. And the electrons that are shown orbiting, and those are shown in green here. Because the protons are positively charged and the electrons are negatively charged, to have a net neutral charge, no net charge, net charge of 0, then you have to have the same number of electrons as you have protons. So carbon has 6 protons, right? That's what makes it carbon. So carbon usually has 6 electrons as well. The same number of electrons. And the atom will also have usually about the same number of neutrons. So 1, 2, 3, 4, 5, 6 neutrons that are also in the nucleus with the protons. Now, does it have to be the same number of neutrons? No, it doesn't, and we'll discuss that in just a bit. So there are a bunch of different elements in the periodic table. Like I said, over 100. How many of those are important to biology? I'm imagining that you're hoping that less than 100. Well, it turns out that very few. In fact, there are only 4 elements that are really in significant abundance in a living thing like ourselves. 4 elements account for 95% of our mass. The biggest in abundance in us isn't carbon, it's actually oxygen, and that's because we're mostly made of water. And water is made of 2 atoms of hydrogen with 1 atom of oxygen, H2O. You've heard of that before. Well, oxygen is more massive than hydrogen, so even though there are twice as many hydrogens, hydrogen contributes less of our total mass. This is how much of us there is, how much weight or amount of substance. So we're mostly oxygen because we're mostly water. But then we have a lot of carbon, almost 20% of us, a lot of hydrogen, again mostly because of the water, but also found in other parts of us, and then nitrogen. Those are the 4 elements, oxygen, carbon, hydrogen, and nitrogen, that make 95% of us. Because we're vertebrate animals, we have bones, we have a lot of calcium, but it's still just over 1%, and a lot of phosphorus that's also in our bones and teeth, and also in other parts of us. All of these other elements together add up to less than a 3%. The less than 3 point something percent. The elements, some of them are in such low amounts that we don't even list them. We just say they're trace. Okay, and obviously we're not even close to the 100 total elements that make up biology. Biology is made of very few elements, mostly carbon, hydrogen, oxygen, and nitrogen.